So, hello everyone, and welcome to this introductory session of a new project design course that we are going to start from next week. And this course is based on steel pedestrian bridges and how to take it up and how to do it as a project. That will be the uh, topic of this course. So, this is the introductory session, and I welcome those who are joining us live on this link. And I also welcome those who are going to watch this link later on. So, we'll just start with the small presentation that we have prepared. And after the presentation is over, then we can take up your queries or questions or discussions. Okay. So let me just start and I'll just share my screen. I hope the voice is properly audible to everyone. Yes. Good morning. Yes. So, as I told you, this is our online project design series course on steel pedestrian bridges. And let me just take you to the agenda of today's session. So, what is expected from a structural engineer? Why we thought that this course should be conducted? A few things about AuxEn and our consultancy firm. Then, how we have evolved, how our thinking has evolved over the past 2 or 3 years, the impact that we are having on the participants, a few things about us, and then we will go to what are the details of the project that we are going to take. So we will be taking an actual steel pedestrian bridge project, and we will be doing it from start to finish. Okay. So I'll give you the details of that project. How will the course flow? Who will be benefiting from the course? What will be the course outcome? How to proceed ahead? And then we will take up your queries. If screen is not clear, I think you need to look at the YouTube settings because everything seems to be okay from my side. Okay. I hope the screen is clearly visible. Okay. So this is going to be the agenda, and I'll take around 40-45 minutes, and then we can take up your queries. If you have any queries, you can just type in your queries into the chat box, and we will take them up if they are relevant. Otherwise, I'll take them up at the end. Okay, good. Let's begin then. So, it's quite a common, I would say, situation that we as structural engineers have, that after doing the engineering we know the theory, the theoretical part is known to us. Okay, but we are not quite confident of its application for an actual project. It does happen, right? Even if we do btech, or even if we have done mtech, even after that we will always feel incompetency in applying our knowledge for an actual project. So there is a gap that is quite evident, and we as a structural engineer feel that there should be a platform where we can apply our learnings for a hands-on actual project. Okay, and whatever are the challenges that as a structural design engineer we face in real projects, we want to understand them. So if these are your doubts, that you know the theory but you're not confident of application for an actual project, or you want to apply the knowledge for hands on a actual project, and you want to understand how the real world challenges are being faced when you do the design, then I think these course series is a good option that we have. Okay, so what is expected of a structural engineer? What Let's say if you are working as a structural consultant, or if you are working as a structural engineer, or if you are looking for a job, then what is expected of us as a structural engineer? So we should have thorough understanding of fundamentals of structural engineering. Obviously, we should have the knowledge of structural system and load paths. It is important that we have the relevant knowledge of we have the knowledge of relevant Indian standards whichever are applicable for your work. You should have a deep understanding of the software, because without software you cannot do anything. So you should have a deep understanding of the working of the software and also experience of practically using it. You should be able to design and detail various elements by taking the outputs from the software, or sometimes doing manual calculations, or sometimes doing both. You should have a basic ability to prepare drawings and details using any computer aided drawing software. So you may not be as proficient as a draftsperson, but at least you should have some basic skills for drafting as well. Then, not only this, not only the design part, but you should also know how to prepare the BOQ, how to make the design calculation reports, how to coordinate with the clients or people from other disciplines, and obviously you should have good verbal written communication skills. So you see, it's if you want to sort of work as a structural engineer, all these facets are equally important. Okay, uh, you should be good at all these things, not just design, not just detailing, but a deep understanding of software, experience of working on actual projects, understanding of relevant Indian standards, ability to draw. Draw means drafting, some drafting skills, how to prepare BOQ. So all those things, all these things are expected and are required from us as a structural engineer. So in these course series, when we are doing an actual project, we try to focus on all these parameters while doing that project. Because when I say we are doing a project, we have to take our project through all these steps. So you will see, and I'll show you that when we are going to conduct this course, we will be focusing on all these aspects. So then the question arises that why this particular course we thought we should conduct. So, through this course, we want to provide a platform to apply the steel design knowledge for an actual steel pedestrian bridge project. Okay. Now, why steel pedestrian bridge project and why not anything else? So, as you must be aware, that majority of consultants or companies that you see, structural consultancies or structural companies, they are mostly involved in residential commercial projects, or they are involved in a few of them are involved in industrial projects. But you will notice not many, or I have written very few of them, are sort of doing the infrastructural projects. So projects like bridges, culverts, uh, interchanges, road interchanges, these projects are usually being done by transportation engineers. Okay, so not only the traffic planning or transportation planning part, but I have seen many transportation engineers also doing the structural design part of it. Why? Because they don't get enough structural engineers who can do these kinds of projects. So there is a big gap for us structural engineers when it comes to infrastructural projects. Okay, now in the infrastructural project, why steel pedestrian bridges? Because if you notice that these steel pedestrian bridges have become an important, I would say, component of any urban landscape today, isn't it? You go to any city, you will see a pedestrian bridge over the road crossing, or you go to railway station, you will see a footover bridge, or you go to any water body, any small water body in the city, you will quite often see a bridge across it. So these days, the pedestrian bridges have become an important part of any urban landscape, and it's not only limited to railway stations or road crossings, but you see them everywhere. In fact, these days, even connecting two buildings, I have seen people making bridges across it, isn't it? So if this building, let's say it's a multi-story building, then at some intermediate height they will create a connection to cross from one side of the building to other. So these have become an important element, the pedestrian bridges. And why I find steel pedestrian bridges very interesting is that actually, as a structural engineer, we can integrate the architectural form, the aesthetics with the structural system. So your bridges may not be boring looking or just dry and drab sort of bridges, but actually you can integrate uh, architectural form aesthetics in the bridge structural system itself. So these structures offer, or I would say, they offer a wide platform for the creativity of structural engineer. Okay, and I'll show you. We have done some bridges in the past where we ourselves came up with the structural system and we ourselves came up with the shape, and it was a very pleasing architectural form as well. So I think that these structures, they give a good chance to the structural engineers to express their creativity. And of course, in a country like India, where there is such a high demand for infrastructural growth, we as a structural engineer should have ability to design in detail such structures and not leave to transportation engineers or transportation planners to do it for us. And obviously, we cannot; these topics cannot be covered in undergraduate or postgraduate curriculum. So we are not able to learn during the coursework, and we are not able to learn on the job as well. So through this project, we are trying to address all these issues, and we will be taking up a complete steel pedestrian bridge project. And from initial planning right till the BOQ and design calculation report, we will be doing everything for this steel pedestrian bridge project. So this is why we thought that a course on such a topic should be conducted. I have just taken a few examples of steel pedestrian bridges uh, being built or already built. So I think this you will appreciate. You will identify this bridge was, I think, recently opened last year, and this is on the, which bridge is this? Yes, anyone from the audience? So this bridge is at this bridge is on the river Sabarmati at Ahmedabad, and I forgot who did the design, but it's quite an interesting design if you see, isn't it? They have taken a three-member element, two elements at the bottom, one element at the top. So the cross section is sort of a triangular cross section. Yes, Atal Bridge, they call it as the Atal Bridge at uh, Ahmedabad, right? So very interesting looking cross section they have taken, and they have taken it in hollow sections. So hollow sections have been used for this uh, bridge, and you will see the support system over here. And if I show you the cross section, so it is something like this. One tube at the top, they are all circular hollow sections, two tubes at the bottom, and then they have connected it with elements in the elevation. So quite a easy system, so to say, but interesting looking system. So this is at Ahmedabad over the river Sabarmati. Another very interesting bridge that I thought I should show you. And who can identify this bridge? Yes, anyone can identify this bridge. So this is also a steel pedestrian bridge. Yes, anyone? No one? So this is an interesting story actually. So you see this is an arch, if you can see, with a rainbow color. So this was an arch, and it was initially supposed to be a arch bridge. Okay, so initially it was supposed to be a deck arch bridge. So there was an arch like this, and a deck was suspended from this, and then there were cables all around, and deck was like this. So this was built at, yes, no one could identify this. Okay, so this was for the 2010 Commonwealth Games at New Delhi. Okay, at New Delhi, and over here you can also see the Jawaharlal Nehru Stadium in the background. So what I am highlighting over here is the Jawaharlal Nehru Stadium in the background. And I think just 10 or 15 days before the Commonwealth Games were to be inaugurated, this deck of the bridge fell down. So this deck of the bridge collapsed. Only this arch remained. Okay. Now the time was so small, the time was so short that a new bridge could not be constructed so soon. So then the Indian Army were called, the Engineer Regiment of Indian Army was called, and the Madras Engineering Group. So Indian Army has three engineering corps: Madras Engineering Group, the Bombay Engineering Group, and the Bengal Engineering Group. So then the engineering group from Madras engineers were called, and then they came up with this bridge system that you see. So you will see a different bridge system with supports over here. So this is a typical army bridge that they construct, and I think within 3 days they just installed this and went away. Okay, so it's quite an interesting structure that when one structure fell down, the Indian Army came in and constructed uh, a makeshift bridge in such a short time. Why I showed it to you? Because they use the Bailey bridge system, and I have talked about it before also. So it's a very what I would say, it's a very efficient system structurally, and you will see all these elements are modular in nature. So even in the piers, what they have done, or even in the columns, what they have done, they have used the same component, or they have used the same module. The same module is provided on in the deck also. All right. So it's a completely modular system, and they installed it in just 3 days. So I just thought I'll just share this with you. I think this it was then dismantled. So the Bailey bridge was later dismantled, and now you have a regular deck bridge once again. So for a temporary phase, they came up with this. Other examples of bridges can be in the cities. You often see these types of bridges. So it's a typical bridge over the road, uh, over a crossing over a road, and you will see a staircase going down over here. You will see a staircase going down over here, and the bridge in the middle. So just a few examples. Why are these staircases always in opposite directions? So if you see one staircase is like this, and the other staircase is going in the opposite direction, why do you think these staircases are always in the opposite direction? So, yeah, I think you will be able to guess it, because you want the lateral stability to this entire system. So, actually, this staircase helps the bridge to give overall lateral stability. So, you'll always find, if I show you the plan, that if this is the plan of my bridge, one staircase will be in this direction, and the other staircase will be in this direction. So these staircases give the lateral stability to the bridge. So just a few examples, just a routine pedestrian bridges you will see everywhere. This is made out of a deep beam sort of a thing, Virindle beam system they have used. So another interesting bridge, I would say. Another uh, interesting, not interesting, this is the usual sort of bridge system. So these types of examples you see everywhere in the urban landscape these days, isn't it? Now before I move on, just a few things about us, Auxen and our consultancy firm. So we are a multidisciplinary consultancy firm, and we do projects in industrial, infrastructural, commercial. So you will see a lot of different aspects of civil structural engineering we do projects on. And then we also established this skill development and training firm in 2015 with my wife. So me and my wife have been involved in these trainings since 2015, and we have conducted several short-term, long-term, offline, online courses in the past so many years. Earlier we used to be offline, and after the COVID we moved completely online. A few uh, pictures from some of our past projects. So you'll see several industrial projects over here. Now I have just added a few slides over here on the practical experience that we have for doing pedestrian bridges. Okay, So because we are conducting a course on this topic, let me just show you a few of the steel pedestrian bridge projects that we have done, or we have conceived, or for which we have prepared some concepts. So in the next few slides, I'll just show you some steel pedestrian bridges that we have done in our consultancy. So this is at Haridwar, and it is called as the Shiv Dhanush Bridge. So the concept and the overall design, uh, we did, our consultancy firm did, and coming up with the shape, which is the shape of a arrow bow Dhanush, and we named it the Shiv Dhanush. So this bridge is at Haridwar Harki Pauri, and it is a very popular bridge. When you go to this place, you will see uh, it's a place where a lot of people click photos and all these things. So this bridge was made completely out of hollow sections, because hollow sections are structurally advantageous. So hollow sections were used. And just last week, me and my wife, we were here at Haridwar. I think just last Saturday we were there, and this is the photos from that place. You will see it needs painting. So I think the government department does the painting every 2 3 years maybe. So this does need painting. I think they will do it in the coming winters or sometime soon. Okay. And these are the live pictures that we had clicked. You will see an interesting detail over here on the bottom right side. So this is an actual pin support that we had developed. So it's a working pin joint, and such joints you will also see in airports these days, isn't it? So this was one of the bridge, and then these are some concepts that we had developed. So this was a bridge that we a concept that we had developed over the river Narmada. So this was a road bridge, not a pedestrian bridge, on Narmada river uh, at Khalghat, near Khandwa. No, Badwa is the actual place. So there we had developed, you will see we had used the same Dhanush concept, and then we had made a crocodile looking system out of all these are structural elements. So we had used this system for a road bridge. Why a crocodile looking element? Because what you say, river Narmada is associated with a crocodile. So the goddess, the Devi Narmada, is associated with a crocodile. So we thought of a crocodile looking shape for the structural element. So this was supposed to be a road bridge. We have given the concept, but it has not moved anywhere till now. The design concept and the design report we have submitted. Then another example of the bridge that we had developed, where we have prepared a concept. So this is at Omkareshwar in Madhya Pradesh, and this is again over the river Narmada, and this is a 500-meter span. Each, sorry, 500-meter length. Each span is 100 meters. Okay, each span is 100 meters. So one, two, three, four, five. Yeah. And the shape is of a wave shape. So we have named it as the Tarang Setu. Tarang means wave. So it's a wave shape representing the waves of river Narmada. And you can see the structural system, and it's a wave like this. And then the deck is completely suspended from these elements. So again, this concept we have developed and submitted. Let's see what happens with this concept in the future. So all these concepts and what should I say, design have been done in our office. Now this is an actual bridge project that we had completed. So I was not doing it myself. Father was doing this. So this is a small suspension bridge in Indore, and it is the only suspension bridge in Indore that we have. So it's a small, I think 40 45 meter span. This is the main span, and I think 20 22.5 meter spans on the other side. So no, it's not that big. No, no, it is smaller. I think it is 30 and 15 maybe. So it's a suspension bridge. a small looking suspension bridge in Indore, and I think it is the only suspension bridge that we have in Indore as of now. Then this was a bridge that we had done in Rewa, Madhya Pradesh. So it's like the bridge I showed you at the Commonwealth Games. So it's a arch, and then there are the arch is suspended from these wires, cables, and then the deck is suspended like this. I think there is a name for this, bowstring, or I forgot. There is some name that you will find. So this was 80 meters, and this is the completed bridge over there. Unfortunately, there was a heavy flooding in this bridge. There was a heavy flooding, and the flood levels bypassed the highest flood level that we had considered. So I think some 6 7 years back, there was a very heavy flood, and the flood levels even bypassed the HFL, and this bridge was unfortunately swept away in the floods. So of course we were not responsible because the water levels bypassed the flood levels, and this was not designed as a submersible bridge. So this unfortunately was swept away. But yeah, it was also an attraction in the uh, I mean, where it was constructed in a biodiversity park. Yeah, it's called as bowstring girder bridge, what Mr. Shashank is writing. Correct. So this was again done in our office, and this was another concept that we had prepared, I think some time in 2015 or 16, over as a railway footover bridge. So the railway people were thinking of providing some interesting concept, not the usual truss bridges that they have. So we had prepared this. This is similar to, if you see the Atal bridge that I just showed it on the river Sabarmati. So somewhat similar. You will see the main circular pipes being taken over here. I think we have taken 8 pipes. So this forms the cross section, and then we have taken elements like these, spiraling the circular cross section. So these are spiraling elements. Okay. So another interesting concept, but unfortunately this is yet at the approval stage only. So we have done a lot of these kinds of steel pedestrian bridges, and therefore I think because we have practical experience, we are, I would say, well placed to discuss this topic as a in the course. Okay, I believe that unless you don't have practical experience, it is not proper to teach that particular topic. Okay. Anyway, so yes, so these were some interesting steel pedestrian bridge concepts and projects that we have done in the past in our office. Now, just a few sessions. Yeah, so these are some pictures of some online, offline sessions that we used to conduct earlier. Nothing quite important. Some technical presentations that we have conducted in the past, and this is the list of all the online courses that we have conducted till now, and our participants have been all across India, uh, from all across the other countries of Indian subcontinent, even from Southeast and West Asia, West Africa, South Africa, Eastern European country participants have also attended our course. And our participants always are a good mix of uh, graduate, postgraduate students, faculty members, practicing engineers, working professionals, consultants. So it's always a very good mix of participants that we have. Now, over the past 2 or 3 years, we have we have devised a two-pronged strategy or approach. So, as I told you, as structural engineers, we require strong theoretical base with software proficiency. Plus, we should also have experience of doing actual projects. So, you may have experience, but you may not have good theoretical base. That is also inadequate. Or you may have a very good theoretical base, but you don't have any practical experience of doing projects. That is also inadequate. So we have developed a two pronged approach where we are trying to uh, address both these issues. Okay, so through our short term courses, we mainly focus on the software proficiency, in-depth understanding, in-depth theoretical understanding, and till now we have conducted around 19 such courses, 10 of which are available on our website to be taken as self-paced courses. And all these courses are quite detailed, ranging up to 60 to 90 hours. So this is more than what you would learn, or this is more than what you would have in an entire semester at your engineering course, isn't it? In an entire semester of coursework for one subject, I think you only get 50-55 hours. Here we are conducting courses which are 60 to 90 hours. So they are quite intense and theoretically very comprehensive. So short-term courses, we through short-term courses we aim to build a strong theoretical base with software proficiency and in-depth understanding, and then we have started with the project design courses, where we discuss, or where the intention is to gain experience of doing an actual project. And this will be the third course in the series. So first course of this project design course we had conducted on a RCC bungalow. The second course we did was on a heavy industrial steel building, and this is the third course. What we are doing is going to be on steel pedestrian bridge. Very good. So before I just move to the details of the project that we are going to do, a few quick slides on our impact on the learners. So those who have seen these presentations before, we always add this slide, and we had conducted an impact assessment survey from our participants, of course, and then we just plotted those data on just understanding what impact we are making on our participants. So, and we marked under different parameters. So if you see our impact the courses are having on the software proficiency, so all your engineers, you will understand this graph. So the average level of the participant when it came to software proficiency was here before taking the course, and after taking the course everyone agreed that they 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 could feel an increased software proficiency, and you will see the dispersion also reducing. So earlier people have different proficiency before, but afterwards it's converging to a high average value. So this is our impact when it comes to software proficiency. When we asked what was the impact of our courses in the codal understanding, so you'll again see from an average value the uh, overall impact showing positive, and the values, if you can see, from 5.75 to 8.5, the average proficiency level when it came to codal understanding. About the concepts, how our courses were able to positively impact the conceptual understanding of a particular subject matter, again you will see before and after. Everyone agreed that it had a positive impact on those participants who are working, and a lot of our participants are working professionals or practicing engineers or consultants. Many of them agreed that uh, they could sense an improved work performance after taking our courses. And in job search also our courses helped. So many of them already had a job, but majority said that our courses helped them in job search as well. And those of our participants who are undergraduate or postgraduate students, many of them also agreed that the impact on their coursework or studies was also quite significant. So as you can see that our through our courses we are not only targeting software proficiency, or not only targeting understanding of codes, but we are looking at overall picture, we are looking at overall development uh, of our participants. Okay, a few things about us. So this is me, and I have done my engineering from GSITS Indore and MTech from IIT Roorkee in 2011. And then I worked for 2.5 years in Pune at Dara Landasa, and since 2014, I have been working in my consultancy firm. And on your left side is Akanksha, my wife, and she has done her engineering from Kota, Engineering College Kota, and she has done her masters from IIT Roorkee. So we were classmates at IIT Roorkee in our masters, and she also has a rich experience of working in different consultancy firm. And since 2014, we have been working at Indore and have been involved in trainings. Very good. So now let's come to the important part and let us discuss the details of this project. So it's very important to understand what is this project going to be that we are going to take up, and how will we uh, do it, or how we will design and develop it. So let me just also open the AutoCAD file for this particular project, and let me just show it to you on screen. Yes. So let me, what will I do? I'll just share my screen. Yes, is this AutoCAD file visible? Yeah, I think you can see this. Right. So this is the AutoCAD drawing of this bridge project, and it's a big intersection of two roads going in opposite direction. You can see. So this is a main road going over here. Okay, this is one road, and then you have a road at an uh, angular intersection. Okay, so to cross this road from one place to so to cross this road, basically you have the transportation engineer came up with this bridge, pedestrian bridge. So this is the staircase, if you can see. So through this staircase you come over here. Then this is a small span to cross this, what should I say, to cross this side and come to this island. Okay, then there will be a column support over here. So they have written pylon, it's a column support. Then comes the main span, so this will be your main span from here to here. So I think it's almost 40-45 meters. This scale was scale of 3, so this is around 45 meters it will come out to be. Okay, so this will be across the road, below is the road. Then you come to the next traffic island. Here again there will be a pylon supporting system. Then it will be the next, so there is no staircase to get down at this location. Okay, so basically the bridge is taking a turn over here, and then you have the second span of this bridge. Again this span will be around 45 meters. Then there will be another column support over here, and then you again cross this small little left turn over here, and then you reach the staircase system. Okay, so basically through this you can traverse from this location, take the stair, and go like this, like this, like this, like this, like this, and just get on the other side. So this is the overall plan of this bridge, and this will be the developed elevation. So this is not a single elevation, it's a complete developed elevation. Don't worry about this structural system right now. We will try to come up with a different structural system. And then these are the staircases. So one will be this staircase, and the other will be this staircase. So this is the pedestrian bridge that we are going to take up. Again, it was an actual project, and you can see the AutoCAD drawing also. And for the structural system, we will try to develop it on our own. We will not follow this. This looks quite boring, in my opinion. So we'll not follow this system. We'll try to come up with our own system. Okay, so it will be an interesting thing that we will do. So this is the project that we are going to conduct. Sorry, that we are going to take up, and I'll just share some details of this project with all of you. So yeah, so it is a pedestrian bridge project in an urban city on a road intersection. The total length is 112 meters, and the maximum span is around 44 meters. Okay. So, I mean, it was a complete thing, right? From here to turns. So, this entire length is 112, and the longest spans are around 44, 45 meters. So, two long spans and then two small spans. The width is around 4 meters. Okay. Generally, pedestrian bridges, around 3-meter pedestrian bridge is good. It's a good width for two-lane traffic. Two-lane traffic means one lane of people going in one direction, the other lane of people going in other direction. So 3 meter into in clear is a very good width for a pedestrian bridge. All right. Okay. So we will be trying to do this complete project using the hollow sections. So I thought that we will do this project using hollow sections because hollow sections provide us good structural efficiency as when it comes to steel sections. Hollow sections have significant advantages over your other sections like angles, channels, etc. So we will be taking up this, and we will be designing our bridge using these sections only, hollow sections. So in the process, you will also learn a few things about the design of hollow sections and how it is different or how it offers significant advantage over the regular sections. We'll try to have a structural system which is modular and repeatable. This is very important and interesting. So it's always economical to come up with a system which is repeatable and which is modular in nature. So just like the Bailey Bridge system, I showed it to you in the Commonwealth Games bridge, everything was modular. So this was one module, and you can repeat the same module everywhere, whether you are using it in column or whether you are using it as part of your steel bridge deck. It was a completely modular system, isn't it? When you are able to achieve modularity, you will always achieve economy in your design. So we'll try to come up with a system, if possible, which is modular and has repeatable units. Okay. And of course, we will design it for the gravity loads, wind loads, earthquake loads, and we will have to follow the IRC standards as well. So the IRC standards that we will be following will be, which IRC standard is required to be followed? Anyone? Yes. Anyone knows which IRC standard? So the IRC standard is the, yes, as Mr. Shashank is saying, we will be following the IRC 6. So IRC 6 is the, you can say, the sort of parent code when it comes to bridges and roads and pavements. So we'll be following the IRC 6, and we will also be following, in addition to IRC 6, there is also some special publications of IRC, and especially for steel pedestrian bridges, we have a special publication number 56 that also we will follow. The system that we will be using, we'll try to use a trust portal system. Trust portal means that, let's say these are my columns and this is my deck, and everything is looking like a truss, but it's a portal arrangement also. Okay, so it's not a just a truss kept on the columns, but it's a complete portal arrangement trusses made out of truss systems. So I am calling it as the truss portal system. So this will become our primary system, and at the bottom we will have fixity with the column pedestal. And then there will be RCC pedestals, isolated foundation will provide as the substructure. So this is the project that we are going to do. And as I told you, we will think of some interesting structural system to follow, and not only a boring looking truss system. We'll think of some interesting system in this course. Okay, I'll encourage you to come up with an interesting looking structural system if you can. All right, and maybe the system that we find most suitable or appropriate, we'll try to take that system in our design. Very good. So yeah, I already showed you all these images. So how will the course flow? So we will follow a complete step-by-step approach. First, because a steel bridge or a bridge is a different topic, I'll have a few I will have some discussion on the different configuration on different structural system that can be adopted for a steel bridge. So we will have some basic conceptual discussions to begin with. Then we will see the general arrangement drawing. I just showed it to you, the general arrangement drawing. So we will discuss and understand the GA drawing provided by the urban planner. Then we will come up with a structural framing system and we'll plan it. Then we will use uh, the software for modeling. So now I'll just discuss after a few slides whether to use STAAD or ETABS. Let me just discuss this point after a couple of slides. So we will do the modeling. Then, of course, the calculation for gravity loads, live loads, pedestrian loads as per the relevant IRC standards. We will also calculate wind and earthquake. Wind will be an important load for these kinds of structures. So we will do the wind load calculations as per the relevant IRC standards. So because this bridge is not on a river or not on a water body, we are not supposed to, or we are not required to consider the load of waves or water currents. But if your bridge you are making on a water body, then you have to also consider the effects of waves or water currents. So those calculations are also given in the IRC 6. Okay, in our case that will not be applicable. Then we will, once the loads are calculated, we will apply the load in the software. Everywhere I've written ETABS/STAAD, will be using one of them or both, maybe, let's see. Then we will do the analysis design using ETABS or STAAD. Then the design of each and every steel member, again using ETABS or STAAD, plus Excel spreadsheets also. Once that is done, then we will do the connection design. Uh, and for connection design, we will use Idea Statica plus some Excel spreadsheets. And so this, till this will be your superstructure. From here will be your substructure. So for substructure, we will design the RCC pedestals and isolated foundation using SAFE. RCC pedestal we will do manually. It will be easy. No, SAFE will not be able to do it for you. So RCC pedestals we can do it manually. And then I will have a few discussions on the drawing development. So we'll not be making complete drawings ourselves. We'll have a discussion on how to develop drawings. What are the important components that need to be included in your drawing? Then we will go to the BOQ preparation, and finally preparation of design calculation report. So this is what we are going to do in this project from start to finish. Now, why to design it on ETABS and not on STAT Pro? I just thought I'll include this slide. So this may be a common question in your mind, that which software to use, and if it's a steel project, STAT Pro is better than ETABS for design. This is a common myth that we have, that when it comes to steel structure, it is to be done using STAT Pro, isn't it? So I think this myth is prevalent because I have seen quite often that senior engineers usually are doing steel design, and junior engineers, junior means by age, young engineers are not usually involved in doing steel design. So I have seen a lot of senior people involved in doing steel structures, senior with age. So when it comes to senior engineers in age, when they are doing steel structures, because they learned STAAD as their first software, they are more comfortable doing STAAD Pro, or they are more comfortable using STAAD Pro for design. So then this sort of myth perpetuates that if you are doing steel design, do it on STAAD. Okay, but uh, I mean, in my past at least 2 years of working on ETABS for steel design, I have come to this conclusion that ETABS is equally competent, sometimes more better when it comes to even steel structures. Okay, so there are a lot of options that are there in ETABS. Of course, there are some disadvantages also, but there are some good features of using ETABS when it comes to steel structures, which which give a distinct edge to the user. So some of the modeling, load application, output and input features that are available in ETABS makes it advantageous to be used over STAT Pro. Of course, there are some problems in ETABS also, and in our previous courses we have discussed in detail about the design problems that ETABS has. But then there are flaws in STAD as well, isn't it? There are problems in STAD as well, and there are some additional problems in the STAD Connect Edition. So those who are using STAD Pro Connect Edition, they must have figured out some additional issues with STAD Pro Connect Edition that were not there in the earlier VATI series. Okay, so there are some additional problems that are there in the Connect edition of STAT Pro. So problems are there in both softwares, and uh, in spite of the problems, we will have to work our way around. So therefore, I thought that it will be interesting to do this project on ETABS. But then many of the engineers or many of the participants messaged me and communicated that most of them are working on STAD instead of ETABS. How many of you are working on STAD, and how many of you are working on ETABS for steel structures? Hello. Yes, those who are watching this live, how many of you are working uh, on steel structures using ETABS, and how many of you are working using STAD? Yes, anyone would like to comment? Mr. Anshul is saying he learned ETABS and STAD and now learning. Okay, he is doing it the other way around. So first he learned using ETABS, sorry, and SAP 2000, and then he started learning using STAD. So those who have used STAD, and I know many people who switched to ETABS later on for steel design also, uh, and they find ETABS to be more convenient and a better software than STAD, even for steel design. Okay, so this myth we need to break first of all, that ETABS is for RCC design and STAD is for steel design. I don't accept this uh, because I have done extensive work in both the softwares, and of course, ETABS has distinct advantage when it comes to the design and detailing and load application part. But in this course, we'll try to see what is the general opinion of our participants. I had initially thought that we will conduct this course using ETABS. It will be very interesting to do that. But however, as many of the participants communicated this thing with me that they would have preferred STAT being used, so this issue I am just keeping it uh, on hold right now. We'll see, or we will try to make a comparison using both softwares. But right now I'm keeping it on hold whether we will be using ETABS or STAT, or one of them or both. We'll see on the general consensus of the participants. Okay, I would have personally preferred doing this project using ETABS because it would have been a new learning for us also, isn't it? Those who are working on STAAD, it will be a new learning for them, that earlier they were doing it using STAAD and now they are switching to ETABS. So it will be a new software learning for them as well. So let's see. Right now, personally, I want to do it using, because I have not done a structure like this using ETABS before. So I also want to maybe use ETABS for it, and let's see what do we do. But in my opinion, ETABS will be more fun to do for such a project as well. Okay, let's see what happens. So a final call will take whether we are using one or two, will take after the due consultation with participants. My preference would be trying to do this project on ETABS. Okay, but yes, just a closing point on this issue, that both are equally competent, and if I had to rate one over the other, I would rate ETABS over STAAD. The STAAD is, they have not upgraded their systems in past so many years. Okay, so there are a lot of issues even with the analysis part in STAAD, and there are a lot of issues when it comes to the load application options. A lot of other features are missing in ETABS. Sorry, a lot of other features are missing in STAAD. So let's see what do we do. My preference, as I said, would be doing this project on ETABS, but a final call we will take after discussing it with our participants. So what are going to be the features? So we will have 25 sessions at least, but as those who have taken the courses with us earlier, you know that we generally extend these number of sessions, and uh, it's always on the higher side that we end up conducting. Okay, yes, Dr. Vinubhai sir is saying that he agrees STAAD is not updated. Yeah, STAAD has a lot of issues these days. I find STAAD very boring, so I don't know. There are some analysis issues also. For example, someone was telling me that STAAD uses only a uh, single core engine or single core processor for analysis. So even your computer may be dual core, or even your uh, computer may be multiple core processor, but STAAD is only able to use one core for analysis. So in big models, STAAD will always take a lot of analysis time also. Okay, and ETABS uses multiple cores for analysis. Of course, there are a lot of other issues in STAAD. Effective length calculation is a big problem in STAAD. Lot of steel design parameters STAAD is not able to take correctly. Even for hollow sections, STAAD will not do it properly. There are a lot of related issues also, and Connect Edition also has issues. Yeah, just give me a minute. Yeah, and even in the Connect Edition, there are some new problems that have come up. Mr. Anshul is saying Connect Edition had issues, but the latest version of V23 has some improvements. In case of steel design, ETABS SAP had problems in forces and bracings, but latest version have corrected it. Okay, what, I don't know what improvements you found out, because someone was in. So there's Mr. Rahul Brijpuria, who is a young engineer in Indore. He had figured out there are a lot of problems in the STAAD Connect edition, and I think he has written to the Bentley systems also. There are some design issues in STAAD Connect edition, what Mr. Rahul Brijpuria figured out, and he has written. So some of the problems that he found, that let's say if you are making a channel section back to back like this, okay, this is the plan view, and let's say you have made it like this in the software, modeled it like this. The software is designing, I don't know why, for this type of configuration. Okay, in built up channel systems, in built up sections. Then there are some problems with the web classification as per IS 800 2007, and there are some related issues that he had found out. So, and these problems were not there in the V8I series. So, these are some new problems in the Connect edition. So, I personally have started not liking STAAD very much these days. Anyway, so what are the features? We will be conducting at least 25 sessions, and as I just said, most of our sessions or most of our courses go beyond the initial estimated number of sessions. So this is an estimate of number of sessions. Our live sessions will be conducted from 8:30 to 10:15 Monday to Friday. But those who are working professionals, because most of our participants are working professionals or faculty members or consultants, so they can join the course as self-paced learning. Okay, the validity for the sessions will be 12 months on the portal, and of course in each session we have doubt solving sessions, and after the course e-certificate will be given. So, who will benefit from the course? Fresh graduates or postgraduates, or engineers who are looking for the job or wanting to start up as consultants, or uh, engineers who are experienced and looking to skill up, or those who want to learn this pedestrian bridge project. I think this has to be cut. Those who want to learn the steel pedestrian bridge design. So even you may be an experienced engineer, but you want to learn this, or looking people wanting just to deep dive for the love of structural engineering. All of you will be benefiting from this course. And what is the outcome? So it is very important to understand and to quantify the expected outcome in any course. So after this course, once we will complete this course, we expect that the participant will understand the steps involved in doing a complete steel pedestrian bridge project, right from the initial planning to final BOQ and design calculation preparation. And of course, the participant in the process becomes comfortable with the relevant Indian and international standards. And we expect the participant to develop confidence and gain necessary skills, and maybe to start his or her own firm, or maybe work for any consultancy company. So after this session, if you want to join, you can get in touch with us. The course fee for this course will be rupees 6,000, and the method and details for how to make the payment we will share you. We will share with you separately, and once you complete the payment, we will add you to our course WhatsApp group, where the link for daily sessions and further updates will be shared. So we will start our course from 22nd of January, Monday, from 8:30 a.m. So the live sessions will start from 22nd of January, Monday. Okay. So some questions that you may have here in mind, that you are a working professional, how can you join this course? So even if you are a working professional, you can join this course as a self-paced learning course. And as I told you, every session that we conduct, we upload it within couple of hours on our portal. And many of you are working professionals, and all our past participants know this, that it's very convenient and comfortable to watch these sessions on our portal also. And if required, we'll conduct some periodic discussion or live interaction session for those who have joined this as a self-paced learning course. Which software are we going to work on? So as I told you, uh, one of these two ETABS are STAAD for modeling and loading analysis, Then ETABS and STAAD and Excel spreadsheets for design of members, Idea Statica and Excel spreadsheets for connection design. We will be using SAFE for RCC pedestal and footing design. RCC pedestal actually we can do manually also. And then we will have discussion using AutoCAD for drawing development. We will use Excel spreadsheets for BOQ preparation and Word for design calculation, report preparation. So these are the softwares we are going to work on. If you are new to structural design, can you join this course? So basically in this course we are looking for people who know the basics of structural steel design. Okay, so if you do not have any basics of structural steel design, then you I will not recommend you to join this course. You can have a look at our comprehensive course that we have done on steel building design and additional courses that we have done on pre-engineered building design, connection design to build your theoretical base for steel design. Okay, so if you are fresh to structural steel design, I will say I will not recommend you to join this course. Instead, I will recommend you to build basics by joining our other steel design courses. So that's all. Thank you for patiently listening. And now if you have any queries or if you have any comments to make, you can do that. Mr. Anshul is saying the improvement in STAD has been made mostly in the case of the LGSF design. Very good. Yes, any queries, questions, comments, you can type in. So we are going to start from 22nd of January, and I expect all of you to join this course. We will have a great time learning, and I think we will come up with some interesting structural system for this bridge. And yeah, yes. Any comments or queries or questions you have? So, Mr. Anshul, as I understand, he is already working on an actual steel pedestrian bridge project in his company. Yeah, the live session timings will be in the morning, 8:30 to this will be the timing for live sessions. But as most of our participants are working professionals or practicing engineers or faculty members, they are not able to join the live timings sometimes. So you can always watch on our portal as self-paced course, and it's very convenient to watch these sessions on the portal also. Mr. Abhishek is asking which is best STAAD in ETABS. It's not about best, I would say which is more suitable. And as I just said, looking at the features that are available and the output input options that are available, ETABS is better than STAAD. Yes, Dr. Saab is saying, yes, thank you, Dr. Saab. So, for your support and presence in our past courses, it really means a lot. Thank you so much. Yes. So then that's it for today. I hope all of you join this course and we have a great time learning. You can watch this session on the YouTube link later on also. It's a YouTube link, so it will be there on the YouTube for you to watch. So that's all. Have a good day. Have a good weekend. And we will see you on 22nd of uh, January. Bye bye.